So next one we start with the square of 8-bit data. So this program I copied already. So just I pasted program here. So this program square of data is nothing but 4 into 4 square. 4 square is nothing but 4 into 4. Okay? So how to save the file? And procedure everything is same. Just I am going for direct execution part. How to check the result? Go for the debug. So here just I open the CALC. So here everything will perform hexadecimal, keep on hexadecimal. So this is 4 into 4. The result is 10. In hexadecimal result is 10. So in decimal what will happen? That is the 16. 4 into 4 means 16. So in hexa it should come 10. Here whatever you are performing everything is in hexa. So that means result will be 10. It has to come. So after run here, so you can check verify again with program is here. 4 into 4 means result should be 10. Where it should be there in accumulator only it will save, because mul AB means always the result will be accumulated. So what is the result here? 10 it is appear. Okay? So same thing, content of we are moving to R1. Where is R1? R1 means 10. Okay? So this line is no need. If you skip also no problem. But for your understanding purpose we are going to write this one. Okay? So this way you need to check the result for square of 8-bit data. So same program, if I want to check a square is nothing but 10. In hexadecimal a equal 10, that hexa equivalent a. Declare. So how to check? I want to check a square, a into a. Declare. In hexa 10 decimal hexa equivalent a. Declare. The same square of 8-bit data. How to check here? So main important thing, one thing you need to remember. Here I am getting the 0. So where it is 0, this error, just make it double click, your cursor will come. It's saying like that, line number 2, or you can read this one. ASM in parenthesis 2, okay, parenthesis 3 means row number 2 and row number 3 are the errors. So what is that error? Undefined symbol. So already I said, when you are loading the values, that is a higher bit. So that means we can say LSB bit and MSB bit. Only one bit is there, A. H stands for hexadecimal number. I want to write A. Already I said if you want to write the values A, B, C, D, E, F in the MSB bit positions, I need to add the zeros. So here also I need to add the zeros for only A to F characters. Then save the file, then you can check. So now errors is completely 0. File means this is very important when you are loading the A to F characters. Before I need to add the zeros, then only it will accept. Okay? So next debug. So what is the result here? Let me recheck. Click on hexa. So a square means a into a. 64. A is nothing but in decimal 10. 10 into 10 100. So you can check in decimal. So its result will be 100. So let me recheck. In hexa it should become 64. So just go for the run here. So run, what is the result? A into A means result is 64. It will be in accumulator. So same thing you can check in R1 also. This is 64. Okay? This way you need to check the result for square of 8-bit data. Okay? So next program we go for the cube 8-bit data. 8-bit data is nothing but here I am taking 4 cube. 4 cube means 4 into 4 into 4. Okay? So before we done square of 8-bit data, one more time I need to perform the multiplication. Okay? And this explanation program already I given in one video, refer that one. Okay? So how to check the result? So already I pasted program here. So save the program and build this one. Okay? And again error 0, go for the debug. So first we need to check, here I am taking the 4 into 4. That result will be in accumulator. Again whatever you got result I am multiplying with again 4. So what is the result? You can check it once. So one time I will take 4 into 4. So again I got 10. So 10 you will get in mul AB. So again I am performing the multiplication AB with 4. So again into 4. That means 40 should be come. So that in decimal what will happen? That is 64. 4 into 4, 16. 16 into 4, 64. But in hexa, that should become 40. So that 40, already you know, mul AB means accumulator itself, it holds the result. So you can just run it. So this one. Just I got 40. So 40 it will be in the accumulator only. Okay. So again you can check one more thing. This is the byte, only the 8-bit data. 8-bit data it is sufficient to hold in accumulator only. If it is come somewhat like here one more 3rd bit and 4th bit, those bits you can check in the base register only. That will be your result. Okay. So this way you can verify the cube of 8-bit data program. Okay. So next we will go for the program to add two 16-bit numbers. Okay. So this program just will make paste here. So just I will make the copy paste. Okay. So here you need to understand, here I made the colon, semicolon. Semicolon is nothing but these are the comments. Comment is nothing but for your understanding purpose we written the few lines. No need to write in programming. Okay. And also comment, it is not non-executable statement. So here we made the semicolon. That means these are also the comment. So that means what it does is second line. So we return the values here. Okay. So you can make comment by using the semicolon also. For example, org is there. If I want to make the comment, just put a semicolon. So it will convert it to this comment also. Or one more thing, you can use something like hash star. Is it clear? So that means completely it becomes a comment. So instead of this one, no sir, instead of I want to use a 2 lines comment means, so here you put the star and this way you can make it comment. Use the colon or you can use this type of to make it as comment. Okay. So here we'll remove this all. Okay. So in this program, what 16-bit data, 16-bit is nothing but one number is the 5A-E1. So just I will type 5A-E1 plus 9C9D. So 9C9D. Result is F77E. So again I return the result F77E. Okay. So these results I am going to store in 7E, it will come R4, and F7 it will come in R5 because I written the program here. After the addition here, so accumulator content it will go R4. That means 7E it will come R4. Next one more time addition here. That means higher byte at the time F7 it will come. F7 I am moving to R5. So let me check. Save. Okay. So go for the debug. So click one time run here. You can check the error. So result 7E. 7E it should be in the R4 register. So where is R4? R4 is here. So R4 content is the 7E. Okay, I got the result. Lower byte it will be in R4. Higher byte F7 it should be in the R5. Where is R5? R5 is here. So this is the F7. Okay, that means 16-bit data is not possible to store in one register. We are going to split it. Okay? Instead of R4 and R5, whatever you want, you can use R6 and R7 also, no problem. That is lovely. Okay? So this program you can check the results like this. Check R4, R4 is here, and R5 you can check it. Okay? So if you want to change the any numbers, okay? If you want to change the any numbers, you can edit in the program section only. Okay? So again one more thing I will repeat. So this is the E1. So lower byte. So lower, when you are loading this number, first you have to load first lower byte. So the E1 you have to load here. Then 5A you have to take the next one. So like that 9D here, 9C here. Okay? This way you need to check the result of 16-bit additions. Okay? So one more last, that is the 16-bit subtraction. So one more program to find subtraction to 16-bit numbers. Okay? So already I copied this program. So save this file. Go for build, again 0 errors. Click on the debug. So here you can check in Calci also. What is the first number? F77E. So here F77E minus of 9C9D. 9C9D. So result is 5A-E1. So same thing, 5A-E1. This is also same. So result of the 16-bit number E1 it will store in R4, 5A it will store in R5. If you compare this program and previous 16-bit addition, only we need to change the instruction, everything almost is same. Okay? So run the next one. So here check the result. E1 should be R4. See here, R4 it will store E1 result. Clear? E1 it should be in the R4. That's why this is in the R4. Next 5A I am going to store. That means this one. A to R5, R2 to A to R4. E1 R4, 5A R5. 5A itself is R4. Okay. So this way you can check the results of the subtraction of the 16-bit numbers. Okay. So whatever I explained, this is a complete experiment too. Already I shared some videos about logic of the programs, how to do, what is the instructions, how to do, it is going to work, everything I explained in the previous videos. And today these two videos I explained about how to check the results of these programs. Okay? And also by seeing these videos and make it practice yourself. So wherever you want to make the changes and try to learn yourself. Okay? And again I will repeat one more thing. So this don't think like that only for this is the lab respective, because microcontroller subject sometimes they can ask the program examples related with your labs also. If you make the practice for the lab programs also, it is very becomes very easier for your the theory programming examples. Okay? As much as possible make this practice all the examples. Okay? Thank you. And one more I will explain, very important. So this just I will take one example here, multiplication for the 3 into 3, 9. Okay? So entire we done only for the 8-bit of arithmetical operation. So sometimes what will happen, 3 into 3 means already got result 9. So instead of 8-bit means this is 4-bit, this is 4-bit, 8-bit. So instead of here 03, I will enter the 103. That means instead of 2 digits, I entered 3 digits. So what will happen? So let me restart. So it will show everything it is error. So that means errors completely it is 0. It's not going to say third bit is it's not possible to take. But logically it is 0 errors. But when you are going for execution, at the time what will happen? Check it once. Go for the line by line execution. When you click this step into move A, 03 is loaded to A. So that is fine. When you go for the next line here, B, 103 has to load in B. But B register loaded into only 03. That means what does that mean? Only it will take the 8-bit data. So that means third bit is not possible to store in the B register. That means obviously it will take only the 2-digit numbers. Is it clear? So this one you need to understand, only this 8-bit means 2 digit only it will consider. So next if you go for next here, so results will be 9. 3 into 3 means 9 will be there. That means third bit automatically it will discard because of these all are the 8-bit registers. Okay? So this is very important and try to make the practice. Thank you so much.